This video is going to take a look at multiple regression, and we're going to start by going to the Analyze menu. We're going to come down to Regression, and we're going to click Linear. And I've already selected variables. This corresponds to information from Chapter 7 in the Mertler and Reinhardt textbook. The dependent variable, life expectancy for males. The independent variables, percent of the population that's urban, the natural log of GDP, or gross domestic product, the birth rate, the natural log of the number of hospital beds, natural log of documents, radio, phone. Okay, so those are the variables. Now we're going to click on statistics. We're going to make sure that we've got estimates, model fit, descriptives, part and partial correlations, and collinearity diagnostics all selected. And we'll click Continue. We're not going to add anything under plots, but here we could, if we wanted to, evaluate some different types of plots, partial plots, or standardized, predicted, and residual, which is a common one to look at for testing the assumptions, as we've seen in other videos. Under Save, if we wanted to, we could create new variables that save our residuals. And you can select a variety, 5 different kinds. Influence statistics, and of course Mahalanobis distance or Cook's, ways of identifying outliers. And predicted values, so forth. We're not going to pick anything this time. Click Continue. Under Options, we're going to leave everything the same here, but we could modify how we exclude cases. We could do so pairwise instead of listwise, but listwise is more common. We could remove the constant from the equation if we wished. And that's all we're going to do. So we're going to click OK. That will generate our results. And we get our descriptive statistics. We get our correlation matrix along with significance and the number of units in the sample or population. This is country data, so there are 107 countries. And as this shows, all of the variables are significantly correlated with one another, and some quite highly. So this actually, when you see these high levels of correlations between independent variables, is one potential concern when it comes to the issue of multicollinearity. And we'll see that's not the only one. But first, let's take a look at the model summary. And we see that the R-square is 0.846 and adjusted to 0.836. So this indicates that about 84% of the variation in male life expectancy is explained by these independent variables. The F statistic is significant. If that's not significant, then we shouldn't interpret any of the results of the analysis, because that would tell us that the independent variables are not having an influence on the dependent variable. And then we come to the coefficient table, and this is where we can see the effects of each individual variable on the dependent, which is life expectancy for males. And it's easier to interpret the standardized coefficients. These depend on the type of unit that's being used, right? So like the percent urban or number of dollars in GDP. So these are all different units. This standardizes them, makes them comparable to one another, so you can see which variables are having the stronger effects. And we can see ln docs has a pretty strong effect at 0.386, as does phone, right? ln phone, 0.547. And then weaker effects are the percent urban and the number of hospital beds. Radio comes in very weakly also. And this is the significance of each individual variable in the regression analysis. And we can see there that the birth rate is significant, and ln docs is significant, and phone is significant. Now I don't think I would end the analysis there, because if we look at the collinearity statistics, we see several variables that for the variance inflation factor far exceed the cutoff of 3, which is the usual number. It's not really a scientific cutoff, it's more ambiguous than that, but that's not a bad rule of thumb. And we can see 1, 2, 3, 4 of the variables exceed that. And with the tolerance statistic, we don't like to exceed 0.10, and you can see several of them do. We only have 1, 2 that meet the cutoff, and then the rest all fall outside the range. So we have some collinearity problems. We also see the condition index. You don't usually like to see that go much above 20, maybe 30. Here we're at 55. That's too high. So we would want to consider, in proceeding with this analysis, to remove some of the highly correlated variables. And hopefully theory will determine which variables will go into the model. And that will summarize our analysis. Thank you.